Hello and welcome friends. In this particular module, I wish to discuss about the elements of material recovery facility. Broadly, we'll cover these contents: pre-processing of MSW, definition and flow of activities in material recovery facility, unit processes for waste transformation, scope of material recovery in India, certain basic operations such as screening, shredding, metal and non-metal separation with air classification. So as you learn the content, you will be able to explain the importance of material recovery facility in municipal solid waste management. We will also be able to explain the waste transformation unit processes and explain basic operations such as screening, shredding, metal and non-metal separation and air classification. So far, we have discussed many things associated with these functional elements. As the waste is collected from the secondary storage, it has to be moved to the transfer station or the processing facility or disposal station. Whatever may be the place where we wish to have that waste transported to. By some or other extent, usually we go for pre-processing of intermingled municipal solid waste. The design of this particular pre-processing, the extent of this particular pre-processing will be depending on the average composition of the incoming waste, its quantity, the availability of the space for the pre-sorting, the subsequent target operation that we wish to go for, such as composting, refuse derived fuel or recyclable collection. Typically, whenever we are going for this particular pre-processing, usually it serves these purposes. Firstly, it allows the mixed solid waste which is being received from the different sources will be segregated into biodegradables, combustibles and to separate certain recyclables. As we do so, this pre-processing will also assist the reduction of the cross-contamination of the various materials to make different products. As this particular concept is essential in order to separate the material into various streams as well as to reduce the cross-contamination among the materials, it can be designed to the required extent of the quantity and the target operation. Accordingly, it may attain very huge scope. The way you see here, the waste is being received, and there are many such operations which are causing the material separation into various streams through series of mechanical electromagnetic conveyors, so that each will be transported to the required extent. Seeing the scope that is depicted through this particular sketch, one can easily understand that this kind of the facility, which is known as material recovery facility, employs combination of manual, mechanical, electromagnetic processes based on the objective of the facility, availability of the equipment, labor to be employed, and the budgetary provisions and associated cost. As we try to understand the various things that are associated with such kind of facility, we have to keep in the mind the concept of the pre-processing. What do you think is that with this particular material recovery facility, the scope is enhanced at very high level. However, the purposes that we discussed on that particular slide are valid for all the discussion that we wish to have. So the first thing that we wish to go for is separating out the white goods. It would be in the form of bulky items like appliances, furniture, etc. Also, there will be certain hazardous content which would be causing that particular cross contamination, hence they need to be removed out of that particular stream. Also, there will be some equipment such as continuously moving conveyor or the table, which will be receiving the mixture of that particular materials. So, as we consider this particular basic concept, here, as you see, the material is being received on this particular table or conveyor. There are people who are working continuously on that particular stream of waste in order to have papers, plastic, paper, textile, cardboard and such things separated from that particular stream of the waste. As it is done, then it is expected to go for the subsequent processes, maybe certain magnetic separators and certain residues that will be going for the ultimate disposal. As you see here, as people are continuously working here, they will be gathering that particular items, and this kind of gathering, collection should be directly placed into the designated containers. Hence, such kind of the container should be immediate vicinity to them. As well, the kind of the waste they are dealing with could be contaminated. It could be even the hazardous. Hence, the use of protection implements is quite a necessity. Here, as we apply this particular manpower, there will be certain limitations for their working, as well as there is a question of the occupational hazards. Hence, the combination of the man and machine in this particular form is also possible. Also, as we are already in the smart city like concepts, Even certain robotic assembly line could be very much useful in order to have the pre-sorting done before going for any of the material recovery or energy recovery processes which are expected to be taken subsequently. Also, this particular material recovery facility is such that it will be following the series of operations in very strategic order. Accordingly, let's say we are trying to have that kind of segregation, separation at say primary, secondary and tertiary level in order to understand the things better. So as you see here, the waste is received and it is moved through the front loader like vehicle. So it will be giving the mixed stream. There is a manual separation. Even as it goes to subsequent line, there will be certain say disc screenings which will be allowing the separation of that particular cardboards. Also, some finishing screens would act subsequently in order to remove the papers like two-dimensional entity, box, say like third dimension or three-dimensional entity. So this will assist us in order to remove say the coarser, bulkier contents. Subsequently, there would be some optical sorters which will be assisting us to remove the non-fiber contaminants so that there won't be any further contamination of that particular component. This could also be facilitated through certain optical sorters. As we move ahead, we'll try to understand how these particular optical sorters work. Ahead, there would be some such mechanisms which would be working on magnetic principles in order to catch the magnetic objects. As we move ahead, there would be certain non-magnetic content. Say for example, there would be aluminum cans. So that cans to be removed, and for that we can make use of certain eddy current separator. Certain content which would be heavier in nature still would be bound with that waste stream. Say for example, in the form of these particular glass bottles, jars. So they would be crushed down and accordingly they would be sent for further processing. Also, again certain optical or manual intervention can be had in order to separate the plastics as well as certain say grades of plastic according to their resin code. I hope you remember that in the last presentation we had discussed about the 7 categories of plastic. So here at the end, these crushed cans, broken glasses, aluminum, plastic are sent for the subsequent center which would be attracting all such separated materials as raw material to manufacture new products. So these 3 slides which I have shown as primary, secondary and tertiary separation is coping up with the requirement of the pre-processing or pre-sorting of MSW. As we consider the Indian circumstances, the typical composition already we have studied over the many slides. Just for sake of convenience, let's assume some such configuration. So there is certain food waste, there is wood, rubber, leather, plastic, paper, cardboard, metal, glasses. So say this particular other we don't know about. It could be mix of lot many things. It may not be having certain say direct recycling recovery aspects. But the way we think of this particular glass, food, paper, cardboard and such things, whatever may be their extent, definitely it has got some potential. So as we discussed in our earlier presentations about the material recovery, certain informal sector picks up this particular part of the resources from the streets as well as certain secondary bins. The generator itself may sell some of such materials to Kabadiwala system. Whatever the stream, ultimately we know that that kind of the wastes are reaching to certain industry which will be using that material as their raw material. So the sizable portion of this particular organic waste, over 81% of this particular municipal solid waste annually, which has got a recyclable potential, goes to ultimate disposal like landfills without receiving the required attention. The various constituents, the way we see on this particular sketch, have the economic value and they are to be recovered, reused or recycled with the revenue generation aspect. Hence, such concepts can properly utilize about 65% of the waste in producing the energy or compost. Say another 10 to 15% to promote the recycling industry, and ultimately the landfill facility can be, say, utilized to such an extent so that the material which is ready to eat would be reduced by 20%. Hence, as we see such kind of the data which is presented through the various studies, I hope you remember about the World Bank study that we discussed earlier. Even this is the Planning Commission report 2014, though the data seem to be old, still it is valid. So, we can conclude that as far as Indian circumstances are concerned, there is enormous potential of the material recovery as far as Indian circumstances are concerned. Only the thing is that there is a necessity to study the source and associated economic feasibility. So, we know now the basics of the material sorting as well as even the certain enlarged version in the form of material recovery facility, and we know the potential as far as Indian circumstances are concerned. Now we can think of the various unit processes which are required for this particular waste transformation. We are already given consideration to this particular pre-sorting as well as manual sorting. One thing as far as this particular manual sorting is concerned, you can attend to that day by day the labor cost is increasing, and as compared to the employed machinery, the processing rate of this labor component is quite low. However, seeing the population of India and seeing the availability of this kind of the labor and even providing the livelihood to them, such kind of the force needs to be inevitably employed as far as the waste transformations are concerned. However, we can also employ certain mechanical sorting techniques which are based on principle of electromagnetics, fluid mechanics, pneumatics, etc. As we employ such kind of the principles, we go for certain specific equipment in order to have the commingled waste separated into various components. So here just we can go for screening, we can go for ferrous metal separation, we can go for air classification, we can go for non-ferrous metal separation, we can go for certain modern techniques, sensor-based separation systems, and we can also employ certain size reduction equipment which could be mechanically driven. Let's try to understand some of the operation principles. So the trommel and rotary screen is very widely used equipment with number of applications and also at number of levels. The way we considered about the primary, secondary, tertiary, so here this kind of the screening can be employed right at the point of generation. It can also be employed at the secondary storages, it can be employed at the transfer station, all the recovery facilities, and even within recovery facilities at the various levels, at the point of the initiation, intermediately, as well as even at the end. As we think of certain landfill like ultimate disposal facility, even at that point, such kind of the trommel or these rotary screens can be used beneficially. This particular trommel or screen controls the material separation by particle size based on the size of the mesh that is employed through this cylindrical shape. So this cylinder has several sections depending on the specific situation. The mesh holes are arranged from small to large with the mesh hole diameter on each sections keeping the same. This cylinder is mounted in the inclined manner with respect to the horizontal, and it is coupled to rotate around its longitudinal axis. So when the material enters in this particular drum screen, due to the inclination and the rotation of that particular roller device, the material through the screen will turn over and roll so that the desired size material will be discharged through the hoppers as you see here. Certain unqualified material which cannot pass through this particular mesh will be discharged through the outlet at the end of the cylindrical drum. Due to the overturning and rolling of this particular material in the drum, the material which is stuck in these particular screen holes can be ejected to prevent the screen from getting blocked. This particular trommel screen should work with the uniform field, which would be avoiding simply cascading. That material will simply keep on rolling and it won't be getting passed through the holes, as well as it would simply move out of the screen. As well, if there is certain, say, larger speed, because of the centrifugal force, the material will simply be adhering along the circumference of that particular screen, and hence the centrifuging will occur. Hence, this screen needs to be rotated with some ideal speed. Say, let's assume that this particular screen is inclined with the inclination of this gamma with respect to this horizontal, and the tangential velocity of the rotation is expressed as Vt. So, as we consider some particle which is moving along this particular circumference, on the verge of its falling, it will be having the centrifuging force as well as the force caused because of the gravity would be balancing with each other. Hence, the vertical component of it can be expressed as mass into acceleration into cos of gamma. It has to be equal to mv square by r. This Vt, which is the tangential velocity, as we know, can be expressed as r omega, where this r is the radius of that particular cylinder, whereas omega is nothing but the critical speed. Hence, as we solve for this particular Vt, we get the expression root of gr cos gamma, whereas the angular speed can be determined as root of g cos gamma by r. Here, this speed is termed as critical speed. So, below this speed, the speed which would be causing non-separation, the way you see here as oversized material and underflow material, the way the material which is getting passed is called as underflow material. The material which is not getting qualified is called as oversized material. So, if this particular required operation is not achieved, then the speed is said to be cataracting speed. So, we can solve certain simple problems. Say, we wish to determine the critical speed for 3 meter diameter trommel which is inclined at 2 degrees. So, we have the expression for the omega. As we substitute the values, here omega can be worked out as 2.56 radian per second, and it will be expressed in terms of revolution per minute as 24.45. The screens could be attaining various forms. One of such forms is vibrating screen. Here the force generated for the separation is because of the vibrating motor. So according to the classification, according to the applications, it can be divided into mine vibrating screen and fine vibrating screen. Also, according to the movement of the track, it can be divided into linear vibrating screen as well as circular vibrating screen. Commercial versions are available. The vibrating screens can handle a wide range of the materials. The high screening efficiency and large processing capacity are favored by many industries. However, the screening for dust and small particles is its weakness. It is also characterized by high power consumption, short life, noise levels are high, and it causes the high dust emission. As one of the processes, we can deal with the ferrous metal separation. Here, we make use of certain magnetic principles, which is very common method for recovering the ferrous scrap after shredding the solid waste. Usually, this kind of separation is expected to occur before going for air classification. Also, when wastes are mass fired in the furnaces, incinerators, the magnetic separator is used to remove the ferrous material from the incinerator ash. The specific location depends on the objective. Say, for example, we wish to avoid the reduction of the wear and tear of any processing mechanism. So prior to that, we have to have this kind of the magnetic separation. Also, if we wish to have the high degree of the purity of the material we wish to separate, we can go for that. And it will solely depend on the efficiency that we wish to have as far as the separations are concerned. Accordingly, here this kind of the recovery systems could attain various forms. So the way you see here, the material is being received after shredding over this particular conveyance. So there is some static magnet. So there is certain say continuous metal. So because of the induction, the material will getting attracted. As the material gets away through this particular continuously moving belt, it will lose the magnetic attraction as it comes out of the magnetic field, and accordingly the material which is magnetic in nature will be getting separated. The material could be fed over the conveyors, passing over certain magnetic drum. In turn, as it moves, it will be adhering over these magnetic drums. The remnant residue will be passing over the next conveyor, whereas as it loses the magnetic area, the material would be getting separated out of the process. One can also make use of air classifiers. So various experimental studies have depicted that steel has settling velocity of 280 to 500 cm per second, paper 10 to 180 cm per second, plastic 3 to 280 cm per second, aluminum 142 to 290 cm per second. So as we see this, each individual has got different settling velocity. So depending on their moving characteristics and settling velocities, depending on their particular densities, we can make use of various configurations. So the way you see here, there is certain say conventional chute type. So material will be fed, there will be undercurrent of the air. So that particular moving current will cause the lighter content to move in the upward direction. Ultimately, it will be reaching to certain cyclone-like equipment for its separation. Further, there could be again the placement of say conveyors, which could also be using certain say magnetic conveyors in order to have the material separated. Also, there could be certain density separators in order to have the lighter fraction and the heavier fraction separated. We can make use of certain zigzag air classifiers. So because of the inertia, material would be simply impinging on that particular surface, and because of losing the say momentum, it will be getting separated out of the stream. Also, we can make use of such open inlet vibrator which should be involving simultaneously vibration, inertial force as well as the air pressure in order to facilitate the separation. So here as you see, there is a provision of some vibrator. One arm is meant for receiving the stranded solid waste, along with there is a movement of the air current. At the lower side, there is a provision of the blower. So, the heavier content would simply be sliding down and accordingly the heavier fraction will be simply removed. Also, as the lighter content is being forced through this particular air current, through the exhaust that light fraction will be removed and the vibration will cause the separation of the material which is having different densities. So, such kind of the open inlet vibrator facilitates the separation of various streams that are existing in the MSW. Also, there could be certain non-ferrous metals like aluminum, copper, zinc, brass, bronze and similar metal alloys. So these metals are costlier, they have certain market value. Hence, we can make use of certain eddy current principle to have the materials removed. Such equipment again could be useful for processing variety of the materials like shredded scrap, say construction and demolition waste, certain packaging waste, even the bottom ashes and say similar lot many applications. Principally, here a non-ferrous metal separator in its basic structure consists of a short stretch of the belt that is driven at the feed end. There is a rapidly rotating permanent magnet system located in its discharge head pulley. In rotation, this pulley system generates the high frequency alternating magnetic fields. This in turn causes the strong eddy currents in the conductive non-ferrous metal parts, which now for their part create their own magnetic fields opposing the outer field. Thus, the non-ferrous parts are diverted from the remaining material stream due to the force impulse and hence the separation of non-ferrous metal. There could be involvement of certain sensor-based techniques. So one can make use of certain infrared technology. So it works on the principle of measuring the reflectivity of the object with light ranging from say 1100 to 2100 nanometers. In this wavelength length, the materials such as plastic, paper, textiles have their own characteristics. These systems can distinguish between the different types of the plastics and even segregate the tetra packs and composite waste properly. However, if the transparency is not to the requisite order, like dark materials, stone, porcelain, it cannot be sorted out from that particular stream. So, such kind of say idiom principles can be used in order to have the material separated out. One more modern technique is detect and root system. So very similar to this particular infrared action, it separates the various grades of the paper, plastic, glass which are not sorted out in the earlier process that we discussed, air classifier. So this system works in two stages. The first stage employ the programmed optical sensor to determine the nature of the different materials, and in the second stage, based on the information received from the sensor, the sorted material is routed to appropriate bin by directional air jet. Also, the X-rays can be used to distinguish between the different types of the waste based on their density. The use of such kind of sensor-based techniques for the separation of the waste is expensive. It requires the large initial investment. However, the waste separation technology is a breakthrough in waste recycling industry because it can enable us to fully recycle the portions of the stream of the municipal solid waste which are otherwise going to landfill-like facility. Also, it could be having small life. It is costly affair, but it facilitates the operation of the achieving the recyclables to finest level, and the basic advantage is it avoids the occupational hazards which could have been caused to the labor who would be involving for that particular material separation, and also it does not have harm to the atmosphere in general. One can go for even the mechanical volume as well as size reduction in order to facilitate the further operations. So the way we discussed about the magnetic separators, the way we discussed about the air classifiers, we wish to have the shredded waste. As well, the shredding would ultimately cause the volume reduction for most of the materials. The materials which are fluffy in nature, obviously, it would cause the enhancement of the volume. Say for example, cotton, textile, plastic, paper. But these particular operations are essentially used in order to reduce the size, reduce the values. Also, as we go for certain, say, anaerobic digester like techniques, we have to have certain particle sizes in order to enhance the digestion operation. So these particular operations are very synonymous to this shredding as well as the grinding, and we wish to have reduction in value to attain the uniform feed and to produce the best size which would be compatible with the operations. So certain flowchart we can consider here. Say for example, making the waste better fuel for the incineration waste recovery facility would require the size reduction techniques, then separation techniques like screening, then having the homogeneous mixture which would be relatively uniform size, adjusting the moisture content, going for the heating values, and ultimately having the energy recovered through combustion incineration like operations. So in this particular presentation, we try to understand the involvement of machinery and their principles in order to remove the material out of that particular waste streams. The techniques that we discussed are helpful for material recovery as well as even the energy recovery. As we move ahead, the concept will be more clear. So thanks for your attention. As we move ahead, we would further discuss some of the equipment which are employed for reduction of the size and separation of municipal solid waste. So by till then, I wish you very happy learning. Thank you.